Hello and welcome to the Deep Sea Podcast, a punk take on a science podcast about everything deep sea. I'm Dr Thomas Lindley. With me is the Professor, Alan Jameson. Hello, Alan.
Hello.
How are you getting on?
I'm all right.
Yeah.
It's getting hot again.
Doesn't pause for long, does it? It gets hot again quickly.
We met up in Singapore. That's the news since the last podcast.
Oh, yeah, that was it. Yeah, the last podcast was hurriedly released from a hotel room in Singapore.
Yeah, we went on roller coasters together.
We did go on roller coasters together as a team-building exercise.
In the dark as well.
It made it much better.
It was one of the ones where your feet hang as well. It wasn't just a normal, run-of-the-mill, everyday roller coaster. This was extreme. I think it was actually a bit better in the dark, because then you can't see the ground. You're kind of less aware of the peril of which you're in.
No, I loved it. There was work done as well, but there was some roller coasters and there were some beers as well.
Yeah.
These things happen.
And whalebones.
We're approaching the perimeter fence of our NDA now. You know those fences in Jurassic Park where they're like,
Yes.
There's an NDA fence next to that.
All right, can't talk about that. The problem is, if we're not allowed to talk about the reason why we're there, it's going to sound like we just went on a complete jolly, because all we can talk about is the roller coasters and the beer, and the art gallery full of horrendous art.
Oh, can you remember her name, the artist? She did a blobfish piece as well, which was brilliant. Like these human-animal hybrid sculptures, and they've got a lot of sort of personality to them, and they, at first glance, they're well into the uncanny valley and make you very uncomfortable and are unnerving, but they've got so much personality and they seem kind and loving, and the humans seem to have a good relationship with them, that you're really sort of challenged by this. So it was interesting from a deep sea perception perspective of the initial human revulsion and maybe getting past that and showing that these things are still sort of beautiful and intricate and interesting at the same time. So I put a deep sea slant on that, and I know Premo was interested in her for the same reasons.
Her name is Patricia Piccinini. It's called We Are Connected. We went to see that. It was morbidly interesting, fascinating, and horrific at the same time.
It was fantastic. It was really good. Yeah, good days out. So will we dive into some news?
Oh no, wait, but before we dive into some news, we have to tell everyone that we did manage to get 8 of us on a stretch golf cart. Like a stretch limousine, but a golf cart.
Oh yeah, that's important.
Well, wait a minute, you haven't asked me what my favourite song is yet.
I've got one this month.
I've got one this week as well, which is not from me. I've got a guest one.
Oh, okay. Well, I'll have mine later anyway. But yeah, you go for yours now. What's your soundtrack of the month?
Well, it was going to be Crazy Frog, because it was the best song ever until Baby Shark came along. But I'm going to put those on the shelf at the moment and go with Spider God, song called Ocean Child, which was sent to me by one of our top 2 favourite Orcadians of all time, Mr. Fraser Retson, who has done himself some damage. He was involved in a very, very manly accident and he's chewed up his leg. So he suggested Spider God, Ocean Child, marine-themed metal.
Oh, well, I'm excited to hear that. Is he all right?
No, I think he's absolutely ruined his leg.
I know he's a keen listener. And one of the manliest people we know. He's a proper outdoor hardworking person.
This is why we're not allowed to tell anyone how he managed to scramble his leg.
Right.
Because it doesn't fit.
The narrative.
Anyway, get well soon, Fraser.
Is it like when I broke my toe on a child gate? I go to sea, I throw grappling hooks, offshore, big tough manly men, and then I break my toe falling down the stairs on the child gate.
Is that your weakness? So if we ever ended up in a space gladiatorial battle, I would bring on a baby gate.
Yeah.
Child security fence and just smack you with that.
Just get me on the toes with that.
I like how you're not questioning why we would end up fighting in a gladiatorial arena in space. But anyway, just take that as a given.
You've been threatening me for our entire relationship. There's always been at some point we're going to fight to the death on the rooftop of a skyscraper during a thunderstorm.
And all I've got is a child gate and you've got a dinosaur bone.
Right. In other news, friend of the show, John Quentin, has released his second book in the Global Watch series, The Verdanski Ultimatum, about sequestering carbon into the deep ocean trenches as part of the Global Watch series of sci-fi novels he's writing.
Do you want to know another interesting fact about that book?
Very much so.
It was inspired by our podcast.
There we go. The loop is closed.
When we talked about the mega CO2 licks, he was quite inspired by that and saw a framework for another exciting story for his lads on Global Watch, and there it was. And then he couldn't find anyone to write the foreword for that one, so he asked me to do it. Oh,
that's cool. I like that it's a feedback loop, because he does do a lot of research in sort of the cutting edge science, and even the sort of fantastical feeling sci-fi elements to his stories have genuine scientific grounding. Like he doesn't actually stretch as far as you realize. He's quite au fait with the latest tech. So no, it's a good fun read. I've read it as well, and it's available now mainly from Amazon. There'll be links in our show notes. The other bit of news that caught my eye is we now know where eels breed, which was a bit of a mystery for a while. So there's still loads we don't know about even familiar species, and the European eel Anguilla. You know, it's one of the early species if it's got a double-barreled name like that, like gorilla. It's usually the first one. And they're a sort of migratory fish. They live most of their life in fresh water, but they disappear off to sea when they're ready to spawn. And they're in a bad way at the moment. I think there's a 95% drop in that population, and we still don't know or understand their full life cycle. So about 100 years ago, Johannes Smit proposed that they bred in the Sargasso Sea, and that was based on larval surveys, but no eggs or spawning adults have ever been sampled to confirm this. So 100 years of one of our key native species that is a food source, and we still don't know quite how they breed. So 26 eels were given satellite tags in the Azores and tracked on this journey, and it was a huge journey, traveling all the way to the Sargasso Sea. They go deep, and 4 of the eels lost their tags due to going over the depth rating of the tag, so going to over 1,400 meters. So they are going deep when they reproduce, despite being river fish for most of their lives. And there was a little local fun story with this, and it happened twice actually. There's often eels in the Little Dove Aquarium up by where we used to live, Alan, in Scotland.
Oh, yeah.
It's a nice little aquarium, nice little round aquarium. If you find yourself in Scotland, give it a little look. But they had a large eel in their tank. They reach this really defined point where they're ready to reproduce. They stop feeding, and even like all their teeth fall out. Their body starts converting everything into reproductive material, basically, either eggs or sperm. So the whole body starts to convert, basically. And at that point, there's no saving the animal. It is going to attempt to reproduce and then die. So they took the roof off in order to get this huge eel out, and used a crane and lifted it out. And then it was released into the sea to go and complete its journey. So it had got nice and fat and tame, living in the aquarium. And then they set it free to have its final journey to hopefully find love in the deep sea. So that was a fun little local story. And I think they've done that twice now, where one of the eels has reached this like reproductive stage.
You could have told that story in a very, very different tone.
A much more horrible tone.
But it was lovely the way you did it. I could see the sunset.
The other nice big paper, actually from your lab, Alan, about are the Hadal Zones isolated islands? So study from friends of the show, Johanna Weston, Heather Stewart, yourself, and a few members of your lab, Alan.
No, they're not actually. They're from Newcastle.
Oh, okay. So this was work started back in Newcastle. So looking at the connectivity between hadal areas, so areas beyond 6,000 meters where we like to specialize, the super deep parts, using a cosmopolitan hadal amphipod, so a species that was found pretty much globally, Bathycalosoma schellenbergi, a little amphipod, and looking at the genetic connectivity between these populations. So looking at 12 isolated hadal features covering the Pacific, Atlantic, Indian, and Southern Oceans. And what they found was that even though we consider this a single species, there's very little gene flow between some of these populations. And so they're effectively isolated in the hadal region, so that the hadal zones are acting like sort of island biology, basically. They're isolating. And I love this term, actually. I don't know who came up with this. They're on their own evolutionary trajectory. Who was it who coined that? I quite like it.
That was me.
Oh, I like it, because that sums it up, because they're not... Well, this sort of gives you interesting considerations on what we consider a species, because once you get on the edge, once you get on the muddy bit of the edge of what we consider a species, there's actually a bit of a grey area, and it's a bit of a judgment call. One species becoming two can be a gradual process as new species develop. So one, actually within this group, was already considered maybe a cryptic species in the Atacama Trench, wasn't it? One of them was already, could be maybe considered a separate.
Yeah, this is the problem. I may have spoken about this before, but the Atacama Trench is one of these ones where no matter what you do in the Marwater Trench, you start to think that you've nailed this, and you can see these interesting trends forming across hadals, and then you throw in the Atacama Trench data and it just ruins it. It's so different from everywhere else. Still not entirely sure why. It's maybe something to do with oxygen, I reckon. But yeah, so those Bathycalosomas, there's a great graph in there which took a bit of work to do, I must admit. That wasn't an easy one to produce, but it's basically genetic distance over geographical distance, and it's fairly linear. So the further away they are, the more they're moving into being something else. But then the Atacama ones are just different, as always. So that was cool. It's really, really nice paper. It was very hard then, because we got it published in Science Advances, which is not easy. So we went through quite a few iterations, and it's complicated. I think for me, it's the pinnacle of sitting on the ship 4 or 5 years ago, wondering how we're going to get any good science out of just racing around the world, doing not a lot of work, but in a lot of different places. And I think that exemplifies what you can do without, rather than doing a massive 2-month stint on some trench. Yeah. If you go to each trench for like 5 days, what can you do that would be of value? And that's it. It's there in a nutshell. So Johanna really nailed it big time. And I think she's actually emotionally exhausted now that it's finally come out. I Apparently she said it was like giving birth to triplets.
That's how writing a paper feels. You've got to hate it by the end.
Yeah.
Oh, well done, gang. That was a good one. While we're in the Atacama Trench, I finally finished naming that species. So one of the 3 new species of Hadal snailfish that we recorded a while back in the Atacama Trench, it now has a proper species designation. It's Paraliparus celti. It's a little blue fish, so we named it after the word for blue in the Kazoo language of the people of Atacama. And yeah, it's a lovely little fish. And what is interesting about it, again with Atacama constantly throwing us curveballs, is that it is a separate colonization of the deep sea, basically, of the Hadal trenches at least. So it's been revealed by genetic work more recently that the Hadal snailfish that we know about, that we have genetic sequences for, they all seem to have a common ancestry. So when we talk about how the snailfish are so well adapted to going super deep, maybe it was one lineage, maybe it was one perfect storm, and it sort of only happened once. But this confirms this is the Paraliparus, which is a more modern genera. It's a more modern group, super abundant in around Antarctica, and it's a whole new branch of the family tree going into the Hadal zone, going into the trenches. So it's a sort of lightning striking twice. It shows that there really is something special about the snailfishes that let them go deeper than other fish. And then on the back of your global abyssal and Hadal fish paper, Alan, the 3 fish that we saw in the Atacama Trench look awfully similar to 3 that were recorded in the South Sandwich Trench in the Southern Ocean.
It gets more complicated than that, because it's relatively believable that Celti is also the one in South Sandwich, but we've never caught them. So earlier this year, when we were talking before about the Diamantina fracture zone, and we pulled up those 2 fish from the deepest point of Australia, one of them is, honestly, it's identical to Celti. The only difference is it's 16,000 kilometres to the west of it. So if it's a sub-Antarctic species, then it should be in Atacama and Diamantina. But between this episode and the next podcast, we will have the answers to that because it's being sequenced right now.
Exciting.
So that's a cool story. If that's the same one, then that's really cool. The other cool story is the second fish we caught in Diamantina is not the same as Celti, and it's not the same as the normal Hadal ones. So there is definitely a third one.
There's some sort of Hadal zone snailfish colonization going on from the southern hemisphere because we're not seeing these. But I think in the amount of weird fishes we've seen in Hadal trenches that unfortunately we've only taken pictures of and we've not got a sample of, there's got to be more genera revealed, aren't they? I think those sort of ethereal morphs, as we've been calling them, they're going to be something new as well. So there's still loads to pick apart with the mystery of the Hadal snailfishes and why they're just so good at it. They're really good at it, and they look happy. Most of the fish you see down there are like, oh, this hurts. But they just seem to be loving it. That can lead on to my soundtrack for this month, basically. So when I came up with that name, with actually help from Osvaldo from Chile, I was worried that it might mean something offensive in another language. It might be a slang term. It's always worth doing a Google search for that name just to make sure it doesn't mean something terrible in another language. And what came up was a ska band, and they have a track called Celti, and the band is a Chilean band called Scatacama, after the Atacama region.
Nice.
So it just seemed like totally serendipitous. It was just like, oh, hell yeah, there's already a song about this fish.
What are you going to do, though? Because if you play your song, you're going to have to tell Fraser he's not getting his. I don't want to be the one to tell Fraser we're not playing his song.
Oh, I'm going to do both.
Okay.
And I've written to the band. I don't know if they'll have an interest in science or a deep sea fish that's very similar to their band and their track. But yeah, I thought I'd write to them anyway. Hey, that's how we ended up with Hadal Zone Express as our theme song.
True.
We just write to these bands and say, do you like science?
Hi.
We heard from one of our old students, Jackson Swan, of Hadal Decapod notoriety, and he's found himself in an interesting place. After, of course, we taught him everything we know, and he owes everything to us. Well, he sent us an update on something unusual he's observed.
Hey, my name is Jackson Swan. I'm a research scientist at the University of Washington and also a former student of Thom and Professor Jameson. So my current research involves me going to the Mekong River quite a bit, and some of the things that I've started to do on my time there, not exactly related to my research, has been to go up to the northern portion on the border between Cambodia and Laos to go study the deep pools. I was there in March of 2022 and decided one day to use, while doing an acoustic survey of the pools, to actually tie a camera to a dive weight and a dive flashlight kind of fashioned in the spirit of Thom and Alan's Hadal landers. I used the acoustic, the echo sounder I was using to see where the fish actually were, and decided to drop down the camera down to a depth of a whopping 75 meters. Now, in the grand scheme of things, this is like a puddle because it's not 7,500 meters, but for a river, I thought this was actually very, very deep, considering the deepest portion of the Mekong I had found that previous year was only 60. Upon reviewing the footage that I pulled up from the bottom, I actually did manage to find some fish, largely what you'd call a pangasius catfish, which is also called an iridescent shark, basically a catfish that kind of looks like a shark, and another thing called a silurid catfish, which kind of almost looks like something you'd see in the deep sea, with a flat head, large teeth, and a long fin, and a tail that ends in a kind of like a macrorid style tail. So actually, upon further investigation of seeing these fish, I kind of realized that these actually were the deepest fish ever recorded in the Mekong. They were also probably the only recordings of these fish in their natural habitat. So that was kind of cool. So I actually wound up sending some of the videos to Alan and Thom, and yeah, it's not as cool as deepest fish ever, but deepest fish in the Mekong for just doing something on my spare time was pretty cool.
So this got me interested in this, and I did a little bit of digging. And there are rivers that go beyond 200 meters deep. So beyond the magic 200-meter line of depth that we consider the deep sea. Is there a word for this? Is there a deep river? So how are we going to learn about that? Who can we talk to? And the person that immediately sort of sprang to mind is Dr Melanie Stiassny. She is the Axelrod Research Curator and Curator in charge of the Department of Ichthyology at the American Museum of Natural History in New York. She also works as a professor at several universities, as a science advisor on various scientific and conservation organizations. She also sits on the editorial board of the Academic Journal of Conservation Biology, and her work focuses on the taxonomy, evolution, and systematics of freshwater fish, specifically in the Lower Congo River in Central Africa. And she knows a lot more about what we've observed here. I'm joined by Dr. Melanie Stiassny. Thanks so much for having a chat with us today, Melanie. Could you start by very broadly explaining your area of research?
Sure. I study freshwater systems, so I feel a bit of a fraud being on a deep sea podcast, but I've worked almost all of my career in Africa, and particularly in Central Africa. And for the last, 10 or so years, I've been working in the Congo Basin. The Congo is the kind of freshwater heart of Africa, and it's just full of fish. It's an extraordinary place. So I've been concentrating on what's called the Lower Congo. So that's where the Congo River kind of falls off the high African plateau and plunges down to the Atlantic Ocean. So it's the tail end of the Congo River. That journey is about 300 kilometers, 350 kilometers. And over that stretch of the Lower Congo, the river drops 280 meters in elevation. Now, it doesn't do it in one drop. It does it in series of drops. So what you have in the Lower Congo is this whole stretch of rapids and then apparently still water and then another rapid and still water all the way down this final stretch of the Congo River, which makes it very, very peculiar. Most big rivers end up in a delta, with slow flowing water. But the Congo's different. The last stretch of it plunges down this series of canyons, and it's super high energy with all of these rapids. So we kind of knew that the Lower Congo was a very interesting place for fish because of these rapids. There'd been one survey of the river, surveyed bits of the Lower Congo in the 1970s, and they'd shown that there were a lot of fish species in the Lower Congo. We started our work in about 2006, and it's ancient history now, but we started and we found more and more species. In fact, we found that in this tiny stretch of the Congo River, so the Lower Congo River is just 2% of the area of the basin. Yet in that 2%, we found over 30% of all of the fishes found in the Congo River itself. So it's an incredibly diverse place for fish. And we also found that nearly 30% of those fishes are only found in the Lower Congo. So it's a real hotspot. Something's been happening there. Evolution's been going crazy there. And we always thought it was because of the rapids. Because what rapids can do to fish, you think if there's water present, a fish can swim around in it. But in fact, if there's very fast flowing water, like a rapid system, that can act as a barrier between populations of species that live above the rapid or below the rapid, and so forth all the way down the river. So it really looked as if, and this is what a lot of our molecular studies have shown, it looks as if the rapids really have divided up fish populations along the lower Congo. And of course, once populations get divided, over time, they can diverge. And over time, you can get speciation occurring. That's one of the things that makes the lower Congo so extraordinary. And it's really extraordinary because this is happening at such small scales. I mean, there are places where the distance from bank to bank is less than half a kilometre. In some places, it's less than a quarter of a kilometre. But where we've been able to sample fish specimens from either side of the banks at certain places, we found that even though the distance separating them was tiny, they might as well have been separated by 1,000 miles. They're just not able to swim across from one side of the river to the other. And we found that these populations are really differentiating into different species at these tiny, tiny geographical scales. So that's what makes the place so extraordinary. The things we've been discovering there have really blown my mind. And perhaps most pertinent for what we are going to be talking about today is the fact that we found incredibly deep holes and canyons in this part of the river, such that we really think this is the deepest river in the world.
That's amazing. This sort of particular area of interest, it started like a good sci-fi novel. It started with a strange-looking fish being washed up on the banks of the Congo, didn't it? And the locals knew about it, but they never saw it alive.
That's absolutely right. We knew the lower Congo was extraordinary. We documented just tons more species than anyone thought were there originally. Very, very diverse. Lots of endemism, that is, lots of species only found in that lower stretch of the lower Congo. And we thought it was due to rapids. Now, at certain points in our study, we were kind of picking up signals of cross-channel population divergence where there didn't seem to be any rapids. So that was kind of strange, so we weren't really sure what was going on. And then we were at a place called Bulu, which is about halfway down the lower Congo. And that's a place where one very strange fish had been found in that original expedition in the 1970s. They found one sample of this very odd cichlid fish that was completely blind and completely depigmented, looked very much like a cave fish. And I'd seen that specimen in the museum actually at Harvard, that one specimen that was caught in the 1970s. And that was all that was known about it. There was this fish at Bulu. We didn't know anything about how it was collected. Well, we went to Bulu and we went there a number of different times. And each time the local people would bring us specimens of this strange fish, but always dead. They found it entrained in little pools around the edges of the river. Never alive, always dead. And that's very, very mysterious. I mean, we thought maybe there are caves somewhere and the caves are connected to the river and this cave fish is somehow dying and getting into the river, but that wasn't the case. There are no caves around that region. So we tried to catch them alive. We never were able to. We caught all sorts of other fish at that place, but we never were able to catch this dead fish, the dead blind cichlid. And then one time we were there, one of the local villagers came to me with one of these fish, and it was just still alive. It was obviously moribund. You could see that it had some trauma hemorrhaging on its body. But as it died, air bubbles began to form under its skin, over its head, and over its gills. Now, it was clearly suffering from what we call catastrophic decompression syndrome. It's basically the fish's equivalent of the bends. Fish can get this if they suddenly come up from depth rapidly upward in the water column and they suffer from decompression. And that's what this fish had. Because we got there where one was just dying, we were able to see this phenomenon of its skin being filled with air and its gills being filled with air. It was dying of the bends. And at that point, we suddenly were like, oh my God, could there be deep water here? And that was really a bit of a wake-up moment, because up until that point, we'd always thought of the lower Congo as this turbulent series of rapids. And rapids are surface water phenomenon, they're shallow water phenomenon. But now we've got an animal that's apparently dying of decompression syndrome. So then the question arose, well, could there be deep water here? And that's finding that fish is really what set the whole thing off, of us then trying to really measure what kind of depths there were in this last stretch of the Congo River.
This feels like a good primer for sort of a sci-fi book. You know, they find someone in the middle of a desert and he's drowned.
Right.
And they can't figure out why.
Perfect.
It's something that we see, like, you know, studying deep sea fish, we certainly see the decompression sickness.
Right,
but I would not be expecting to see that in something I'd found in a river.
Right, exactly. I mean, it's kind of a weird comparison that you bring that up, because obviously I do feel a bit of a fraud because when we're going to talk about how deep the Congo is and how we found out how deep it is, it ain't as deep as the deep sea in the ocean. But to be honest with you, what we found in the lower Congo, these deep canyons, and the water is so turbulent down there, and that's what makes it so different from the deep sea. It's so turbulent, even though the one place where we really studied it and we found depths of over 160 meters in a river, that's phenomenal. But the water down there is so turbulent that there's no way you could get down there. I mean, we got down to the bottom of the Marianas Trench, right?
Yeah.
Even though the canyons in the Congo are nothing like as deep as that, it would be virtually impossible to get down there.
That's incredible.
The difference between the turbulence and depth is kind of unheard of. I mean, there's depth in the sea, sure, but it's still and silent and calm down there. Yeah. And that's absolutely not the case in the lower Congo. So even though there might be similarities about some of the things we're finding in these deep canyons in the lower Congo, it ain't like the sea at all, because it's just completely crazy in terms of water currents and plumes and recycling columns of water going up hundreds of meters. It's really a cacophony down there.
So if we were to put ourselves into this fish's shoes, what is that like as a habitat? What's the ecology like down there? How is it making a life? It sounds totally inhospitable.
Yeah, I know, it does. It's crazy. I mean, basically, we don't know because we can't get down there. And also, it's only our assumption that the fish is living at depths in this region of Bulu, where we were using, in collaboration with a team from the US Geological Survey and from my museum, the American Museum of Natural History in New York City, we got together and they deployed some really sophisticated equipment, which again, I think marine enthusiasts will know about. It's acoustic Doppler current profilers. So using the ADCP along with echo sounders, we were able to measure not just the depth and the profile of the channel at Bulu, but we were also able to visualize what the water's doing. So we could actually visualize the water currents when some are shooting up and some are shooting straight down, hugely turbulent and hugely deep. And finding that deep canyon, which, as I said, was over 160 meters deep at that point. There are other places that are even deeper, but that canyon at that point is where most of the dead cichlids. So the local name for this strange blind cichlid is very odd. It's Mondeli bureau, and Mondeli is Congolese for white, and bureau is a corruption of bureau in French, office. So if for some reason they're calling it the white man's office, I don't know. But anyway, yeah, it's really bizarre. But anyway, nearly all of the dead Mondeli bureau that the local people were finding were around that canyon. And the fact that, you only ever find it dead, the fact that it seems to be dying from decompression syndrome, we kind of made the assumption that it's got to be living down there, probably very close to the rocky bottom. The whole of the lower Congo is kind of rocky constrained. It's basically almost like a rift. So it's really, really rocky. So probably we assume that Mondeli bureau is living down deep at the bottom of that canyon. And every now and again, it gets maybe swept up. It swims a little bit too high in the water, and it gets swept into one of these jets of water that's just plunging from the depths right up to the top, to the surface. If it gets entrained in that, it won't be able to swim against that current, and it will pop up to the surface like a cork with decompression syndrome. That's our assumption. Now, another thing is that you could say, well, could you look in its stomach or its gut and see what it's eating? Well, again, as you deep sea people know, decompressed fish, very often its gas bladder expands. If it has a gas bladder, a lot of deep sea fish don't, but these freshwater fishes do have a gas bladder. And as these poor Mondeli bureau are swept up to the surface and they're decompressing, their gas bladders just expand and burst and actually push everything out of the gut and stomach. So all of the fish that we looked at had pretty much empty guts, so we've got no idea what they're eating down there.
It's really hanging on to its secrets, isn't it?
It really is, yeah. But then one interesting thing was that we started looking at not just the simple simple genetics of who's related to who, but looking at the genomics, what's controlling this strange blindness and the odd lack of pigment and all of the features about this very odd fish. So we started looking at its genome and comparing it with other cichlid genomes. And we came across some kind of interesting things, just very serendipitously. We were actually looking for what are the genes controlling the loss of eye or the loss of vision and depigmentation. But just coincidentally, we found that not only was this fish blind and depigmented, but we found clues in its genome that really did strongly suggest that we're right, that it must be living at depth. So, for example, we found that it had a whole series of what are called loss of function mutations. And it had a series of these in genes associated with repairing ultraviolet damage. Now, we're constantly repairing DNA damage from ultraviolet light, but this strange cichlid has lost the function in a lot of these ultraviolet repair gene mechanisms. So that's kind of interesting. It kind of suggests to me that it's living at depth, is not exposed to any ultraviolet light whatsoever, and therefore doesn't need to maintain all of these genes for ultraviolet damage repair to its DNA, which is quite costly to keep all of those genes. Yeah, so to me, that kind of indicates that, yeah, this guy never sees any ultraviolet light.
At any stage in their life history.
Right, exactly.
Yeah, there's no larval stage in the shallows. That's going to be a permanent issue.
Absolutely, yeah. So that was one finding that we found looking at the genome. And then the other thing, which is really cool, that food availability is going to be very stochastic. We don't know what's down there, but we do know that things could get swept down in some of these currents, maybe insect larvae or eggs or whatever. But it's not very common. Food is going to only be stochastically available. And what we found is that this Mondelli bureau has also lost function in one of the genes, a gene called spexin. So the downregulation or the loss of function in the spexin gene results in the loss of appetite suppression. And that means binge eating.
Wow.
So it's really cool. So this gene spexin is also found in humans, and it's downregulated in obese humans, and obese rats, they found, have downregulated it. Anyway, so the fact that it's lost the function of its spexin gene makes perfect sense if you're living in an environment where food is only sporadically available. And when that food's available, you binge eat. And you binge eat and you binge eat and you store lots of fat, lots of lipids. When the food's there, you eat it and you store it. And then, of course, there's long periods of starvation. And then more food becomes available. So again, the indication from the genome is that, yeah, we're right, this animal really is living very deep in the canyon. But as I say, we can't prove it. We can't actually go down there.
There's some deep sea sort of modes of life here. Certainly the loss of vision, the loss of UV resistance, and that way of feeding. We see that in a lot of our deep sea scavengers, things that will gorge themselves.
Right. It would be super cool to investigate whether the same is true in some of those deep sea fishes. Because we did a comparison with, I don't know if your listeners will know about it, but there's a very famous kind of model organism. It's Mexican blind characin, a blind cavefish, and it's been studied a lot, and a lot is known about its genome. One of the interesting things is that we found when I started CT scanning some bodies of the Mondelli bureau and some of these Astyanax mexicanus, this Mexican blind cavefish, you can actually see all of these fat lipid globules in the heads of the Mondelli bureau, and you can see them in the heads of the Astyanax, the cavefish. So they're doing the same thing. They're binge eating. But what's really interesting is it's a different gene in the Mexican cave tetra. It's a completely different gene. It's a mutation in the melanocortin 4 receptor, which is not spexin at all. And interestingly, that melanocortin 4 receptor gene is linked to anorexia in humans, which is very interesting stuff. But anyway, so the point is, Mondelli bureau living at the bottom of a canyon, completely different habitat than the Mexican blind cavefish living in still water in a cave. Yet they're both doing the same thing because food is only sporadically available.
The same conclusion in different ways.
Exactly. It's the same morphology, this sequestration of fat, but a completely different gene underlying it. So it would be really cool for someone to do some genomics on some of these deep sea fishes to see how they're doing it or if they're doing it.
That'd be incredible. We've got some great samples already, and I think we're just getting to the stage of full genome mapping.
Cool.
To get to the bottom. So
yeah,
there might even be databases already on GenBank I could point you towards.
Yeah, it would be totally cool. I mean, so we have a number of candidate genes associated with this particular phenomenon, which we think is this, living at great depths in a river. Yeah, very cool.
Oh, that would be good fun. Yeah, there are absolutely parallels here. And that's why we went off-piste a little bit to speak to both a cave biologist and yourself, because there is convergent evolution. Just how you studied the blind cave fish, it informed the differences that you were seeing. And by us as deep sea biologists, talking to people who study caves and talk to people who study deep freshwater fish, we can tease out the common narratives, and it informs you so much more about evolution because it's the same experiment run with different parameters.
Exactly. Yeah, it's very exciting. I mean, I've given a talk and got a similar response from marine biologists who are saying, my God, the parallels here are just amazing. And yeah, we could really kind of tease out what's going on. I mean, I think this phenomenon of convergent evolution is so pervasive. And now we have the tools to kind of look at what are the genomics underpinning it, which makes it super exciting. And I don't think we've got time to go into the rest of it, but, one of the other things that makes the Lower Congo system so amazing is the fact, now these are not in deep water, but the fact that we've found about 5 or 6 examples of blind, depigmented fishes from completely different families. So not from the cichlids, but from all over the fish tree of life. In the Lower Congo, they've thrown up these, what we're calling cryptophthalmic, you get hidden-eyed species that are endemic, are only found in the Lower Congo. And so we've got this wonderful example of convergent evolution, complicated by the fact that these things we don't think are living at depth. We think the only one that's really living at depth is the cichlid, the Mondelli bureau. But all of these others, the catfishes, the elephant snoutfishes, the spiny eels, all of these different families have thrown up a cryptophthalmic, bizarre-looking species in the Lower Congo. So they're clearly responding to whatever's driving this, and we could speculate about what that is, but whatever it is, it's independently in different lineages have thrown up these convergent phenotypes multiple times just in this short stretch of river. So there are examples of convergence all over the planet, sure, but this is all happening within a short stretch of one river across the fish tree of life. It's terrific.
That is amazing. Yeah, no wonder you're so sort of married to it. What a fantastic place to study fish evolution.
It really is. It's been called, evolution on steroids. It really seems to be that. So I'm going to be doing it for a lot longer. And one of the things that's been so wonderful about working in the Congo is making these relationships with students and professors at the University of Kinshasa, which is the capital of the Democratic Republic of Congo, and at the University in Brazzaville, which is the capital of the Republic of Congo. So 2 Congos just sitting either side of the river. And I've had the opportunity to work with the Congolese scientists there, and it's just been terrific. A lot of my previous students who've worked with me on this project are now professors at those 2 universities, and it's just great to see them carrying on the work, because that's one of the big things, is that we need to be building in-country expertise so that these kind of studies and understanding the evolution and sustainable management of these fish resources is fundamentally so important. So doing a lot of this training has been very, very rewarding. And now a lot of my former students who are now professors are having their own students, Congolese students. So that makes me feel there's a very bright future for ichthyology in the Congo.
Fantastic. Are there any conservation concerns? Obviously, this is an incredibly fragile system. You've got populations which are totally isolated that might not occupy a huge space. It'd be easy to wipe out.
Yeah, I've told you that it drops 280 meters in 300 kilometers. Well, a lot of that drop is towards the end of the stretch of the Lower Congo around a place called Inga. And there are 2 small dams there at the moment, but there are plans to dam the entire Lower Congo at that at that place. And it's been estimated that if they do that, they're going to get they potentially would get over 2 times the output of the Three Gorges Dam, the world's largest dam at the moment. Wow. If they dam the Lower Congo, it could be twice that. Such plans have been on the books for the last 50 years. It has yet to happen. But if it does happen, it would be catastrophic for this whole system and for all of the people who live in that area. That's the main threat at the moment for this stretch of the Congo.
And the best way sort of around that is to understand it and then to relay that understanding and to build local capacity and local passion for a whole ecosystem nobody knew about until strange things washed up.
Absolutely. Yep. Yeah.
Thanks so much for your time.
Oh, my pleasure. Always happy to chat about my work.
The truly passionate scientists are. Thanks so much, Melanie. We'll be in touch. That was fun. Fascinating to see really well-known groups like the cichlids. So anyone who's kept tropical fish, you might have had a ram or a crebensis or Oscars, all these like common pet fish. There are members of that family who more closely resemble deep-sea fish and are blind and colourless or cave fish probably more closely. So there are some real unusual oddballs out there.
This is a genuine question. What is the deepest freshwater fish in the world?
Who is the deepest freshwater fish?
It's Cutoidea sculpins.
Oh.
And there's 2 species. They are translucent fish that typically live in open waters of about 100 to 500 metres, but they are found to 1,600 metres or so in Lake Baikal.
Wow, this is cool.
Yeah. Problem with Lake Baikal, I mean, that'd be a really cool place to study, but it happens to be in Siberia, and it spends most of the year covered in ice, and Siberia is Russian. So right now it's not probably the best place to go, but it's fascinating. There's some major stats on it. It's like something like 20% of the world's fresh water is in Lake Baikal, because it's that big and that deep. It's a big rift lake.
Wow, I need to do some more reading on this. I like the sounds of this. Because the sculpins aren't a million miles away from the snailfish, genetically. So that would be interesting.
Yeah. Oh, yeah. Have a look. There's also, like, I think it's 350 species of amphipod in there, and the amphipods are also what they call gigantism, which is, they're actually pretty big, but they sort of resemble something closer to Antarctica than they do anywhere else. So.
And completely fresh water?
Yeah.
Wow. So did it get cut off from the sea and then gradually became fresh? Because these are sort of marine groups, I feel.
You're going to have to Google that, but my understanding of a rift lake is that it's opened up and then filled with water.
I suppose that makes sense.
Given where it is, I can't see when that would last be part of an ocean. Who knows? I don't know. Do some homework, everybody. Go out and Google Lake Baikal.
That may well be a future episode if we can find someone we can actually talk to about that.
Well, that's mental. It's 1,600 metres deep, freshwater lake.
I do want to go there.
It's fascinating.
That was interesting. I like learning a whole new angle.
There you go.
And I've got to learn about deep-sea lakes as well. Yeah, what do we call it? Can we use our same terms? Can we say, like, the freshwater bathyal? How do we talk about, like,
I don't know.
1,000 metres deep, but it's fresh?
It comes back to this. I got into a bit of a publishing argument recently where somebody wrote a comment on our paper, and let's not do a particular deep dive on that one. But anyway, I wrote a reply back to it, and I'm still sort of, like, arguing over where or why or who cares what the depth of the deep sea is. I certainly don't believe it's 200 metres. I'm a big advocate for being at least 1,000.
I think politically it's 200.
Because if you think about like what Tracy Sutton was talking about, of like this huge layer of biomass, they're only deep sea fish during the day.
Yeah.
During the night, they're all up at the surface, right? And the 200 metre one was arguably about putting it off the continental shelf, where photosynthesis no longer takes place. We're basing it on plants, and I just think 200 metres is, who knows? I don't know. It's
partly plants and it seems to be partly territory.
Yeah.
It's about sort of, it's not a depth thing. It's more of a lateral thing about how far you are from land. It's about the sort of shelf depth.
And just when you think of the ocean being 10,900 metres deep, to just draw a line at 200 and say, this is shallow and this is deep, it's just, I just think it's utterly pointless. But then, so what do you call, if it's, because it's not a sea, because you're in a river, or Lake Baikal, you're in a lake, they're not deep sea anymore, because it's deep lake and deep river.
And it's not going to be structured in the same way.
I guess it must be deep Bathio River.
I like it.
But again, we're already trying to pigeonhole it, right? We're already trying to draw these lines, so why bother? Just like deep fish in the Congo River.
Well, we need words to be able to communicate it, but yeah, they're always going to be maybe overgeneralizations. Yeah, I like this stuff.
Deep sea's far too broad. I think it's really far too broad. You can call pretty much anything deep sea. It just makes it sound more exciting. Oh, wait a minute. We called the Deep Sea Podcast the Deep Sea Podcast.
Yeah, we did. But I think that says what it does on the tin kind of thing. Yeah, Thom and Al go deep might be a bit a bit more open-ended.
Nobody sinks slower. That was the old classic.
Nobody sinks lower than Thom and Al. Good stuff. Have we talked about your TEDx talk?
Oh, I forgot about that. No, yeah, Ted quite liked my TEDx. So I actually did it last December. That's how long ago it was. But they decided it was worthy of special attention and special promotion, so they sat on it for 10 months. Weirdly, they put it out on YouTube and then said, we want copyright forms, we want this, we want that, all this extra other information, and then you've got 24 hours to do it, sort of thing. So, a couple of days last week, so I was scrambling. It's like, you could have told me this 10 months ago. But anyway, it's all very cool. I reckon it'll get up to like 30-something million views in the end. So it's just me rambling on about deep sea and much the same as what I do here, to be honest.
Yeah.
But it was a good thing to do.
It's great. It's great. A good, concise 12-minute run through the deep sea. So there'll definitely be links up to this if you haven't seen it already on our social media. But yeah, really nice. Looks like you had good fun as well. There's a few laughs in there.
Oh, I did have a few laughs, yeah. You got to have a few. Actually, the funny wee story about that is at one point, I didn't see the slides until I was on the stage, right? So I put them together, and then the guy who was organising it decided he was going to make some changes and put in some title slides and a few black ones, whatever.
Thanks, guy who's organising it.
Yeah, thanks, man. I mean, it worked out great in the end, because when I said something like, this is what the deep sea really looks like, I was expecting to see a picture with the lights on of the seafloor, and actually it went to just completely black slide, which everybody laughed at, because it's like, yeah, of course.
Was that off the cuff?
Yeah, I didn't know you put a black slide in there, and then it's like, actually that worked really well. It's a great gag. I'm going to use that again.
I'm impressed that you did that on the spot, because that comes across really natural. Oh, good on you. That would have had me floundering. That would have had me like, oh no, something's not right. I think I might be doing one in Newcastle, but I don't think it's going to have the same gravitas. But it'll be good fun.
Well, it depends. They all go to TED. Every time you do one, if it's an official TEDx talk, they all go to New York, and somebody sits and watches them, and they decide if it just goes out on a normal TEDx channel, or they put it in a box and then sit on it for 10 months. Exciting
stuff. So yeah, definitely putting links in for that. Yeah, and it's a nice, good, fun 12 minutes. So it came across really well.
Hello. This is oceanographer and explorer Don Walsh. Today's program will be on the different densities of the water in the oceans and how it affects activities there. The density of seawater is primarily affected by two items. One, the amount of dissolved salts in the water and its temperature. Adding salts makes, if you will, the seawater more dense, heavier, and warm water is lighter than cold water. So you have those two variables, and also you could consider the change in pressure at great depths as somehow affecting its density. The density of seawater affects the buoyancy of objects floating in that seawater. In other words, the thicker, if you will, to be non-scientific about it, the thicker the water, the better buoyancy you have. And I offer as an example the Great Salt Lake in Utah, where people can float very easily in that very thick water, or the Dead Sea in Israel, where you can almost walk on the water because there's so many dissolved salts in it. Now consider the case of a military submarine operating the sea. Ideally, a submarine which displaces thousands of tons of seawater must be as neutrally buoyant as possible. That is, somewhere in the water column where it's operating, it is not too heavy so it sinks, or not too light so it floats up to the top. Neutral buoyancy. And that's achieved by using various tanks inside the submarine to add water for weight, or to get rid of water to get rid of weight. Now consider if you're operating near an area where there's a lot of input of fresh water into the ocean, and therefore you have a change of density in that immediate area. Because what will happen is you will suddenly get heavy, and you have to work pretty hard to regain neutral buoyancy. You're not going to crash or anything like that, but an unalert watch on a submarine can find themselves very much surprised when a situation like this happens. But the other thing to keep in mind is that fresh water, understandably, floats on top of salty water. Being less dense, it forms a lens on the surface of the ocean, so that the further away you get from the source, like a river outlet, the less fresh water you're going to have at any given depth in the ocean. However, a really important factor in the changes in seawater density is in the propagation of sound, because the more dense a substance is, the faster sound travels. And you can tell this by the difference in sound when you knock on something solid and when you're trying to transmit that same sound through seawater. For submariners, it's a matter of life and death to be able to hear what's around them and at the same time be as quiet as possible. If the density of seawater was uniform from the sea surface to the sea floor, then all of this would be easily predicted through standardized charts and tables prepared by some distant expert. In other words, one size will fit all. However, this is not the case. In fact, one can consider the variability of density of seawater in the vicinity of your submarine to be more like a highly stirred mass. So this means that the submarine itself must have an onboard capability of measuring sound velocity in order to be as sneaky as possible. And you do this as frequently as possible to stay aware of the acoustic situation around your ship. During my 14 years in submarines, including a couple of years as the captain of one, I was able to position my submarine almost right next to a surface ship who had his sonar pinging away so loudly that we could actually hear it through the hull of the submarine. And in other cases, you think you're safe because you're several miles from that ship, and he can hear you as if you're just next door. And this means you have to be constantly aware of changes in the sound velocity in your immediate vicinity. And the way to do this, either to your benefit, is to move up and down in the water column and then checking the variability of sound or the density of the water throughout the water column to get close to the bad guys or just remain hidden so he can't hear you. And although it's been 50 years since I last operated in submarines, these principles still apply today to modern nuclear submarines of all navies. That is, hear and not be heard. Well, that's all I've got for now, and thank you for listening.
Anyway, to change the subject completely, do you want another conspiracy theory?
No, they make me sad, but go on.
So I got an email from Victor just the other day saying, have you heard about this stuff? Someone's asked me about it. Do you have any water samples from the bottom of the Philippine Trench? And I was like, what are you talking about? And there's a gas called deuterium. I think I'm pronouncing that right. Deuterium. It's a heavy hydrogen.
Oh.
So it's a heavier and stable isotope of ordinary hydrogen. So it's known as the fuel of the future. Right? So it's something to do with this. It's going to solve the world's energy crisis, and there's billions and billions of dollars of this gas, but it's only at the bottom of the Philippine Trench. And of course, we took water samples from there, so Victor's kind of like, well, can you have a look and see? Can you just go and test it for deuterium? You know, it's like you do. And I was sort of looking at it going, I've never heard of this before. So I said to him, look, give me half an hour and I'll go and have a quick look into this and see what, because I've never heard of it. And it's just utter nonsense. So I got this quote from the guy who claims to be a...
Is it like perpetual motion machines, free energy?
Perpetual motion does come into it on this very quote. So this is a guy who's a scientist. This goes back a number of years, right? It's sort of churning around. And this is a direct quote. He says, a big deposit of 868 miles long, 52 miles at widest point, and 3 miles at its deepest point, replenished by nature 24 hours a day after deuterium travels more than 12,000 kilometers from Central America to the Philippines through the span of the Pacific Ocean, when planet Earth turns on its axis from west to east in unending perpetual motion. I'm like, so I've copied that back to Victor, said, this is the biggest load of rubbish I've ever heard in my life. So there's some really good site. Do you know the Rappler.com? Someone when it does the truth or fiction sort of thing. So they had a good deep dive into it, and they're just like, it's absolute rubbish. And there's a quote in there somewhere that says, if you believe deuterium deposits lie at the bottom of the Philippine Deep, you're all set to buy green cheese from the moon. So, basically, this guy's claiming this billions and billions of dollars of this amazing new green energy, hydrogen fuel, whatever the hell it is all sitting here just there for the taking, and everyone's getting very excited by it, and it's just utter nonsense.
I don't understand how mass is just perpetually generated. That was the idea, by the spinning of the planet.
This thing is like flipping back and forward every 24 hours between Central America and the Philippines. I mean, surely that water takes like 1,000 years to get around there. You know, it's just such utter nonsense.
We've got unfettered access to information, and what we decide to do is to lie to each other and play yes and. We're essentially one massive improvisation troupe. It's just like, oh, there's all this free green energy. Yeah. And it comes from the moon, and there's an ice wall, and the moon's a hologram, and yeah, they all stack on top of each other.
Yeah, this guy's saying his economic potential is about 12 million barrels per day, with a capacity price at $7 per barrel that could reach 84 million per day, or 30.6 billion per year, enough to wipe out all existing foreign debts of the Philippine government in 1 year. It's like, that sounds almost too good to be true, don't you think? Like,
it's not, though, it's true.
Wouldn't someone have gone out and had a wee look for that, if that was a thing? Because getting water from the bottom of the trench is actually not that hard.
Well, there'd be massive incentive. We know how to do it, I think, is the thing. If you wanted water from the trench, at least to prove if this stuff's there. Do you know we found a load more helium recently? So I have a pet peeve with, because I'm a scientist and I hate fun, with helium balloons, because that is a finite resource once it escapes up into the atmosphere. It is absolutely necessary for things like MRI machines and, some crucial both medical and scientific stuff. And it's a finite resource and we play with it. We play with it and make balloons, which then fly off and make litter, but never mind.
But you forget, it makes your voice squeaky as well.
It does make your voice squeaky. Oh, and does it make crocodiles deep because of something about their vocal cords? I'm really off piece now. But yeah, anyway, a big deposit has been found and it means it's not going to run out immediately. So I will allow you to enjoy balloons for a bit longer, but I will frown at your children's birthday party and probably spoil the fun a little bit. I'm great fun out and about.
But I know you're saying if you fill a balloon, then the balloon pops and then that's wasted helium. But if you were to do the squeaky voice thing as well, is that okay? Because then you've got two things from it. You've got the balloon and the squeaky voice.
It's less wasteful. It's better. It's not okay, it's better.
Is that okay? Because remember, single-use plastics are banned. If you use a straw twice, that's okay. So, on that logic, if you do squeaky voice and balloon, then it's perfectly justified. I got another question for you. This is genuinely a deep-sea question that I thought we should discuss. So, Hyperid amphipod, the one that lives in the salp?
Oh, yeah.
Phronema, which was called Sedentaria. The one that's consistently always said to be the one that inspired the design of the alien in the Alien films.
Yeah.
The xenomorph. That's absolute rubbish, isn't it?
It's Geiger, so it's all penises and vaginas.
Yes.
You don't have to look for any more inspiration. Every single design, the alien itself, is a penis and vagina. Yeah, it's genitals.
And it looks a lot like all Geiger's work.
Yeah.
Why do people keep saying this little transparent amphipod the size of a fingernail is somehow related to the influence of the Alien film? When did that start? We need to do a deep dive on that one.
Yeah, let's do our due diligence, because maybe we'll be surprised and proven to be wrong, but it's Geiger, it's always genitals.
Yeah, and what's weird as well, I think when you look at it, it doesn't actually look like the alien at all.
No, not at all.
It really doesn't. If it had a big, long, black head with like some sort of like retractable inner jaw or something like that.
But the dragonfish do look like chestbursters.
Yeah, I've just seen an article today with mentioned it again.
That I could believe.
So, okay, so there's two things. Let's put this out to the audience. Let's collectively do our homework. Where did that rumour start, if it's true at all? The second one, I think we need someone with a bit of math background for this. There's a phrase that says, by 2050, there'll be more plastic in the sea than fish. Now, I'm going to stick my neck out here and say I think that is absolute rubbish.
And I think it's by weight, so at least it's not numerical. But yeah, I see that a lot as well.
I just think that is total and utter rubbish. It's a lot. It's really doing the rounds because it's such a lovely soundbite that it's too good to be true. But
it's the headline.
Yeah. I just don't buy it at all. I did actually have a little quick look into it, and I think I did find out who started it.
I found the reference. I didn't pull it apart.
Right, it was in an annual report of a particular foundation, who I think were the ones that did it. But it seems to me that there's some wild extrapolation going on there somewhere. Because when you think about the biomass of fish in the sea, I think this sometimes because, I spend a lot of time at sea. I spend a lot of time looking over the side of the boat just because you're bored or you're working or whatever you're doing. And yes, plastic is everywhere, but you could go hours between pieces. There's some areas where it's really, really bad. I just think it's utter rubbish. I think it's just scaremongering, really bad extrapolations. But it serves a purpose, right? It's trying to scare people into addressing plastic use, whatever. So it does have a place, but at the same time, I just don't think it's true.
But we've got to be trustworthy. If we're going to try and be the voice of reason, we can't exaggerate. I mean, things are bad enough to not have to exaggerate. So we have to hold ourselves to higher levels because there are people who just don't want to believe this as a choice rather than as an empirical evidence thing. I heard recently about a fella who runs a ferry, and despite all of the data points and all of the historical evidence, he hasn't had to adjust the height of his ferry landing, so he doesn't believe in ocean rise. So billions of data points, but some guy frowning out of his window saying well, I've not had to adjust the height of the jetty. I give up.
Wow.
I give up.
Yeah. Well, it's nice to know it was all just been a false alarm. Back to business, everybody.
While we touched on monsters, a fan of the show, Eldritch Enthusiast, did some lovely fan art of me. And for the first time in a very, very long time, I changed my Twitter picture. Yeah, I really liked it. It's immensely and unrealistically flattering. And after looking at it, I'm continually disappointed by my actual face. But yeah, it was really nice getting fan art from the listeners.
Well, I'm glad you said that because I was going to say something similar. That I do think it does you well, that picture. You do look lovely. It doesn't necessarily bear any truth. But
to the haggard remains of me.
Did they do two of you?
Yes.
I saw one that was white, another one had like snailfish flying all over the place.
Oh, it's brilliant. And there's a a giant squid in the background with a glowing eye. Oh, it's great. But yeah, I was so flattered by the first one. They did me another one, which was very cool. It's weird to get fan art. People are listening to this.
But are they, though?
Are they just drawing pictures, finding people they look like?
Just to recap on our homework, we have to find out who started the alien amphipod story and find out whether or not more plastic in fish by 2050 is actually a thing. Wasn't it something else? Oh, you need to go and look into Lake Baikal.
Oh yeah, I want to do that.
We're going to have a read.
Like a bit of fresh water. And that concludes this episode of the Deep Sea Podcast. Don't forget we have an email address, podcast@amatosoceanic.com. It'll be in the show notes. And write in. Have a chat. Any questions, any comments? It'd be even better if you recorded them as a sound file and we could play them on the show. So until the next time, we'll deep see you next time, and I abyss you already. The Deep Sea Podcast is supported by our company, Amatus Oceanic. If you'd like to explore the deep sea for yourself, we can provide the technology and know-how to allow you to do that. Or if you'd like to bring the deep sea to your audience through storytelling, fact-checking, or presentations, we can help with that as well. We want the deep sea to be accessible to everyone. Well, I'll tell you what, we go full circular economy. You open the balloon, you inhale, you do the squeaky voice into a new balloon.
Ooh.
Yeah, there you go. I'll come to that birthday party. There's your perpetual motion machine. There's your free energy. Free squeaky voice forever.
It's a perpetual motion and you have a human being in the middle of it who's obviously not going to be able to do it until he's going to fall asleep at 10 o'clock.
Hey, none of them work. None of the perpetual motion machines work, but there's still whole websites dedicated to people shouting about magnets.
I know, that's a pretty lousy design.
Okay then, okay. When that person gets tired, they can recovery breath kiss that into the lungs of another person and sort of pass the baton.
But that's not perpetual motion at all.
It's taken turns. It's as well thought out as any of the other ones.